Welcome back. In the last video, we covered squeezing, unsqueezing, and permuting, which I'm not going to lie, these concepts are quite a lot to take in, but just so you're aware of them, remember, what are they working towards? They're helping us fix shape and dimension issues with our tensors, which is one of the most common issues in deep learning and neural networks. And I issued you the little challenge of changing a value of x original to highlight the fact that permute returns a different view of the original tensor. And a view in PyTorch shares memory with that original tensor. So if we change the value at 0, 0, 0 of x original to, in my case, 728218, it happens, the same value gets copied across to x permuted. So with that being said, we looked at selecting data from tensors here, and this is using a technique called indexing. So let's just rehash that, because this is another thing that can be a little bit of a hurdle when first working with multidimensional tensors. So let's see how we can select data from tensors with indexing. So if you've ever done indexing with PyTorch is similar to indexing with NumPy. If you've ever worked with NumPy and you've done indexing, selecting data from arrays, NumPy uses an array as its main data type, PyTorch uses tensors. It's very similar. So let's again start by creating a tensor. And again, I'm just going to add a few code cells here so I can make my screen right in the middle. Now we're going to import torch. Again, we don't need to import torch all the time, just so you can run the notebook from here later on. X equals torch dot. Let's create a range again, just nice and simple. This is how I like to work out the fundamentals too, is just create a small range, reshape it, and the reshape has to be compatible with the original dimension. So we'll go 1, 3, 3. And why is this? Because torch A range is going to return us 9 values, because it's from the start here to the end -1, and then 1 times 3 times 3 is what? Is 9. So let's have a look. X dot shape. Beautiful. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 of size 1. So we have, this is the outer bracket here, which is going to contain all of this. And then we have 3, which is this one here. 1, 2, 3. And then we have 3, which is 1, 2, 3. Now let's work with this. Let's index on our new tensor. So let's see what happens when we get x0. This is going to index on the first bracket. So we get this one here. So we've indexed on the first dimension here, or the 0th dimension, on this 1 here, which is why we get what's inside here. And then let's try again. Let's index on the middle bracket. So dimension 1. So we got to go x, and then 0, and then 0. Let's see what happens there. Now, is this the same as going x0, 0? It is. There we go. So it depends on what you want to use. Sometimes I prefer to go like this, so I know that I'm getting the first bracket and then the 0th version of that first bracket. So then we have these 3 values here. Now, what do you think is going to happen if we index on the 3rd dimension or the 2nd dimension here? Well, let's find out. So let's index on the most inner bracket, which is last dimension. So we have x, 0, 0, 0. What number is this going to give us back? If x0 on the 0th dimension gives us back this middle tensor, and then if x0, 0 gives us back the 0th index of the middle tensor, if we go x0, 0, 0 is going to give us the 0th tensor, the 0th index, and the 0th element. A lot to take in there. But what we've done is we've just broken it down step by step. We've got this first 0 targets this outer bracket and returns us all of this. And then 0, 0 targets this first because of this first 0. And then the 0 here targets this. And then if we go 0, 0, 0, we target this, then we target this, and then we get this back because we are getting the 0th index here. So if we change this to 1, what do we get back? 2. And if we change these all to 1, what will we get? This is a bit of a trivia here, or a challenge. So we're going 1, 1, 1. Let's see what happens. Oh no, did you catch that before I ran the code? I did that one quite quickly. We have index 1 is out of bounds. Why is that? Well, because this dimension is only 1 here. So we can only index on the 0. That's where it gets a little bit confusing, because this says 1, but because it's only got 0 dimension, we can only index on the 0th dimension. But what if we do 0, 1, 1? What does that give us? 5. Beautiful. So I'd like to issue you the challenge of, how about getting number 9? How would you get number 9? So rearrange this code to get number 9. That's your challenge. Now I just want to show you as well is you can also use, you might see this, the semicolon, to select all of a target dimension. So let's say we wanted to get all of the 0th dimension, but the 0th element from that. We can get 1, 2, 3. And then let's say we want to say, get all values of the 0th and 1st dimensions, but only index 1 of the 2nd dimension. Oh, that was a mouthful. But get all values of 0th and 1st dimensions, but only index 1 of 2nd dimension. So let's break this down step by step. We want all values of 0th and 1st dimensions, but only index 1 of the 2nd dimension. We press enter, shift enter, 2, 5, 8. So what did we get there? 2, 5, 8. Okay, so we've got all elements of the 0th and 1st dimension, but then, so which will return us this thing here, but then we only want 2, 5, 8, which is the 1st element here of the 2nd dimension, which is this 3 there. So quite confusing, but with some practice, you can figure out how to select almost any numbers you want from any kind of tensor that you have. So now let's try again. Get all values of the 0 dimension, but only the 1 index value of the 1st and 2nd dimension. So what might this look like? Let's break it down again. So we'll come down here, X, and we're going to go all values of the 0 dimension because 0 comes first. And then we want only the 1 index value of the 1st and only the 1 index value of the 2nd. What is this going to give us? 5. Oh, we selected the middle tensor. So really, this line of code is exactly the same as this line of code here, except we've got the square brackets on the outside here because we've got this semicolon there. So if we change this to a 0, we remove that. But because we've got the semicolon there, we've selected all the dimensions, so we get back a square bracket there. Something to keep in mind. Finally, let's just go one more. So get index 0 of 0th and 1st dimension and all values of 2nd dimension. So x 0, 0. So 0th index of 0 and 1st dimension, 0, 0. And all values of the 2nd dimension. What have we just done here? We've got tensor 1, 2, 3. Lovely. This code again is equivalent to what we've done up here. This has a semicolon on the end, but what this line explicitly says without the semicolon is, hey, give us all the values on the remaining dimension there. So my challenge for you is to take this tensor that we've got here and index on it to return 9. So I'll write down here, index on x to return 9. So if we have a look at x, as well as index on x to return 3, 6, 9. So these values here. So give those both a go, and I'll see you in the next video.